All right, the next thing I wanted to talk about is you're also going to see a few questions that talk about how much of the atmosphere is above you at a certain location. And it may be complicated and it may sound confusing, but it's actually not that bad. And here's how it works. So the average pressure near the surface of the Earth, near sea level, is 1,000 millibars. And then as you rise up in the atmosphere, remember, pressure decreases with height. Why? Because you have less atmosphere above you. And what we can actually do is use that pressure to tell us how much atmosphere is above us. If 1,000 millibars of pressure is near sea level, 800 millibars would be 80% of the atmosphere above me. 80% of 1,000 is 800. So all you really need to do when determining how much of the atmosphere is above you is take your pressure level, whatever it is, and just drop the last zero. And that gives you a percentage. So for example, 100% of the atmosphere is above 1,000 millibars. 50% of the atmosphere is above 500 millibars. 10% of the atmosphere is above 100 millibars. So really, again, just drop that last zero. Or if you don't like dropping things, you can also just put a decimal between each of these. So 20% above 200, 30% above 300, 40% above 400, and so on. Now with that said, unfortunately that first example of the US standard atmosphere, this thing right here, used a method that you're never going to use again. And here's what I mean. All future STUV diagrams we draw in this class, you are not going to use altitude as your y-coordinate. Sorry, this cursor likes to disappear from me from time to time. You are not going to use altitude as your y-coordinate. In all future exercises, all future plots, you're actually going to use pressure as your y-coordinate. And the reason why is because that is a more accurate and more useful coordinate for meteorologists. For example, let's say I'm an airplane, or I'm in an airplane and I'm flying over a location. I don't necessarily know exactly what height I'm at because I can't just send a ruler out of the side of the airplane and extend it all the way down to the surface, but I can determine what my air pressure is. And then using my air pressure, I can then calculate what my height is. So for all future reference, we're actually going to be using air pressure as our y-coordinate. All right, so the last thing I'm going to do, and this is more from the application section of the textbook or of this particular investigation, is I'm going to help you to plot data that's taken from an actual weather balloon launch. And this was actually taken earlier on this day. I'm recording this video on Tuesday, January 15th, 2019. And I just pulled data straight up from Oakland International Airport. They did a weather balloon launch. They do one twice a day. They're one of 70 weather stations that does this. And this is data that I pulled from that weather balloon launch. And if you're ever interested in pulling weather data from a weather balloon launch, or even like actually seeing it plotted on a STUV diagram, I can actually show you that. I can actually post a link to that in the comments of this video. I'm more than happy to do that. Okay, with that said, let me switch over here. I'm going to use a different color now. I'll use red, and I'm going to use my pen. And basically all you do is you just plot points. But again, for the purpose of plotting the points right now, we're only going to look at pressure, at pressure as our y-coordinate and temperature as our x-coordinate. So pressure as our y-coordinate, so that's going to be our y, temperature as our x-coordinate. All right? And let's do that. So, plotting the different points here, the first point is 10.8 at 1,011 millibars. And 1,011 millibars is right near the surface. And, sorry, the cursor's not showing up on my screen. It likes to do a disappearing act. Okay, there it is. And what I'm going to do is just put it up there. And then the next one was 1,011. So I'm going to place a dot there. And then all I'm going to do, draw a line between the two. And then the next one was 925 and 7.2. 925 is going to be halfway between 950 and 900. That's down here. And, oops, actually I made a mistake. Sorry about that. Let me actually erase that. I actually plotted between -10 and 0. Hey, blooper. Okay, let's fix that. So let me get my cursor to appear again. And all that you have to do is, in this case, we're just going to plot it like that. So I'm still plotting those 2 points, still connecting a line between them, just like that. And then at 925, I'm going to plot another dot at 7.2, which would actually be right around here. So 7.2, very close to the same temperature as the US standard atmosphere. At 850, that's going to be the line between 900 and 800. So 900 and 800. So between 900 and 800. And actually, I'm not going to do this.